All right, this is our next to last section. And this is exponential properties. Now, y'all mad at me or something? I ain't never seen y'all this quiet. What's the matter with y'all? Well, at least one person can talk. The rest of y'all mad at me? Y'all just don't want to talk to me. Okay. Exponential properties. What is an exponent? It's one of those things that's up there in the top corner. An exponent is another way of writing an expression. That's supposed to have two S's in it. That has a repeating operation. So x times x times x times x is equal to x to the fourth. Y times y, blah, 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 is y to the seventh. 3 to the sixth power is equal to 729. And delta to the fifth power is equal to multiplying delta 5 times. 2 to the fifth power is equal to 32. So anytime you multiply something over and over and over, that's just like an exponent. Okay? That's the basic definition of an exponent. Now, when the bases are the same, that's a good thing. When they're different, it means nothing. We can't do anything about it. We can't simplify it. We can't. The only thing you can do is plug and chug. You can't do anything unless the bases are the same. Now, what is a base? The base is the variable part. The exponent is up in the top right-hand corner. The base, there's two parts. There are three parts. There's a coefficient. In this case, that would be 1. And this is coefficient 1. And then there's a base. And then there's an exponent. If the bases are the same, we can work with them. If the bases are not the same, there's nothing we can do. If you have x to the fourth plus y to the third over z to the second, then your answer is x to the fourth plus y to the third plus over z to the second. There's nothing you can do to simplify that. Versus if you have the same base, if you're multiplying, you add the what? Add the exponents. Now, if you've had pre-algebra before, then you've heard add the exponents before. Hopefully you have. Okay? What are the rules of exponents? They should be on the next slide. Nope, not yet. All right, so take, for instance, this one. So look for same bases. These are the same bases. These are the same bases. I should have used black there instead of white. My bad. So x to the fourth times x to the seventh, we can do something with that. X to the fourth over x to the second, we can do something with that. X to the fourth times x to the fifth divided by x to the third, we can do something with that because all the bases are the same. Now the rules of exponents start off with the product rule. Write that one down. That one says x to the n times x to the m is equal to x to the n plus m. So the bases have to be the same. If the bases are the same and you're multiplying, then you add the what? Add the exponents. And this is the term that you should be familiar with. Add the exponents. If the bases are the same, you add the exponents. So let's try some. X to the third times x to the fourth x to the negative 3 times x to the negative 7, x to the 1/2 times x to the 3/4. All right, work on those three. So, what's 3 plus 4? So, what's negative 3 plus a negative 7? Negative 10. Now, I will address this later. This answer right here is not finished, but we'll address it later. Okay? So those of you that have had pre-algebra before and you remember what to do here, yes, we'll address that later, but not right now. We got to add the exponents. Well, what do we got to have to add the exponents? Common denominator, Hubert. That's right, class. Now, what's the answer? X to the what? X to the 5/4. I don't know where that came from. Oh, I know where it came from. I was adding in my head when I wrote that. I'm sorry. Yeah. So that's called adding the exponents, meaning you have the product rule. Comprende? Everybody feel good about that? All right. The quotient rule. Write that one down. Quotient rule says if you have the same basis and you're dividing, what can you do to the exponents? Subtract them. So, if you divide using the quotient rule, you subtract the exponents. Now you got to be careful on this one, because when you're subtracting exponents, you got to put the minus sign in front of the second one, and that changes things. So let's do something simple. X to the 7th over x to the 3rd, or 2nd. Now that comes out, we subtract the exponent. And that comes out x to the what? X to the 5th. Now that was pretty simple. But what if you're given some negatives? X to the 4th over x to the negative 3rd. And x to the negative 3 over x to the negative 7. All right, do those two. So this one, you do exactly like I did the first time. X to the 4 minus a what? -3. Now there's two negatives together. What I tell you about that? That changes to what? Which is x to the x to the -3 minus what? 7. You owe $3. You owe $7. What do you owe? What? That's supposed to be a plus. Okay, I messed up. I thought I put a plus. My bad. So negative, I wanted it to be a positive 7. I wanted to show you what happened. -7 plus -3 plus 7 is what? Negative or forward. I'm still trying to do it. Okay. So just remember this, especially this one. Right there. Because these will get you if you're not careful. Make sure you put that negative sign in front of your negative because you are subtracting. Now, let me ask you this. Could I have brought, well, we can't do that yet until I go over the next couple of properties, so I'll just shut up. There's the next property called the power rule. Now, the power rule says, and you should be highlighting each one of these rules. This is the number 3 rule. The power rule says that if you raise a power to another power, you multiply the what? Exponents. Excuse me. Multiply the exponents. So far, we add the exponents when multiplying, we subtract the exponents when dividing, and when you raise a exponent to another exponent, you multiply. There's 4 problems. So, what is 4 times 2? X to the 8th. What's -2 times 7? -14. Now this one, this 1 is raised to the first power, and this 2 is raised to the first power. So what is my answer? 1 to the 4th over what? 2 to the 4th. What's 1 to the 4th? 1. What's 2 to the 4th? 16. Class. What's 1/4 times 2? X to the 1/2. Good. So that's the power rule. Power rule is used a good bit. The first three, the product rule, the power rule, and the quotient rule, and the power rule, they're used a good bit because they're mathematical. They are based on mathematics, where the next two is based on how something looks. Okay? That's the inverse rule. There's one thing in mathematics that we don't like, and that is a negative what? Exponent. Now, scientific notation, you can have a negative exponent. That's not what I'm talking about. I'm talking about in just algebra and math. Don't want a negative exponent. It's ugly. So you need to fix it. And the way that you fix it is with the inverse rule. The inverse rule says that if you have a negative exponent, flip it, and it will turn into a positive exponent. Now there is about a half a page derivation of this, or you can just take my word for it. I suggest you take my word for it. Anytime you've got a negative exponent, determine where the exponent is in relation to being a whole number or a fraction. Like in this problem, we're given 1 over x to the negative n. So this is a fraction because I have a 1 on top of it. If I flip it, then it becomes x to the n over 1. As soon as you bring that x to the negative n upstairs, it changes to x to the n. Well, what if you had it the other direction? Well, that's fine. Let's say you had a problem x, oops, sorry about that, x to the negative n, and you were told that you needed to redo that. Well, what is any number over, if a whole number, it's over 1, right? So if I have x to the negative n and I want to change it, then I put it over 1 and I what? I flip it. So it depends on what you're given. I'll go slow. So this one is more of aesthetics. Now, can I go back to the quotient rule? Let me ask you a question. Now that you know the inverse rule, can I go back to the quotient rule problem? Okay. Oh, I can't do that with the, I have to hit backspace. Hold on. And now I'm not doing either one. There we go. Let me go back to the I'm just going to have to bear with me. I'm doing two different things. Okay. Oh, I've erased it because it's transparency. I can't go back. All right. Well, I'll figure it out in a minute. Let me just go back to where I was. There you go. Let's take some examples of what I did in the previous problem with the quotient rule. Let's say I have one that looks like this. X to the 7th over x to the negative 2. Now, do I have to do the quotient rule with this, or could I use the inverse rule and take it upstairs? You can use the inverse rule and take it upstairs. There is no set order to do these things. So if I wanted to take this negative 2 and take it upstairs, that becomes x to the 7th times what? X to the 2nd, and I use the product rule, and I get x to the 7 plus 2, which is equal to what? Or I could have done the quotient rule and say x to the 7 minus what? -2, which will give me x to the 7 plus 2, which is equal to what? Do I get the same thing? There is no rule that says you have to use one law over the other. In the outcome, you'll come out with the same what? You'll come out with the same answer if you did everything legally. So let's do a nerd. About 1 over x to the -3rd, x to the -3rd over y to the -6th, x to the -4th over x squared, and x to the -5th over x to the -2. All right, work those four. I don't care how you work them. You can work them any way you want to. But since you're in the inverse rule, I would probably suggest doing them by the inverse first. All right. This one says that I can bring this what? Just flip it. Oops. Sorry. And that'll give me x to the 3rd over what? Which is x to the 3rd. This one, I'll take this downstairs, and I'll take this upstairs, and what? Anything else I can do? No. Why? Why can I not do anything else? Different bases. And you take your handy dandy highlighter out. Different bases. You can move them, but you can't do anything else with them. This one can come up. This one can go down. And then you can use, that'd be x to the 2nd over x to the 5th. And then you could do the quotient rule, x to the 2 minus 5, which is equal to x to the negative 3. And then that's over 1, bring that downstairs. 1 over x to the 3rd. Is that the only way to do that problem? No. You could have brought this up, and then you could have used the power rule, that's the same thing. You could have brought this down, used the power rule, you would have got the same thing. No, there is no set way. As long as you abide by the rules, you can get the same answer. So don't come up to me and you don't know all 3 rules or all 4 rules and say, well, I did this and it didn't come out right. If it doesn't come out right, then you've done something what? Wrong. Because it doesn't matter which order you do the exponential rules in, you still get the same answer. Okay? Well, let's try another one. Another rule. The inverse power rule. Again, this is mostly because you don't like to see a negative number. I hardly ever use this rule. It says that if you have a term in parentheses raised to an exponent, and the exponent on the outside is negative, you can flip what's on the inside and it'll make it positive. And like I said, sometimes people just use it because they don't want a negative exponent. The last two rules are usually used at the end of the problem when you have an answer and it has a negative exponent in it. What do you do with it? Well, number 4 and number 5, that would be where you use most of this. Where number 1, 2, and 3 is the actual mechanics of the laws, the actual working, simplifying. I guess you could say number 4 and 5 is to make it look what? Pretty. It's the makeup laws. Make it look pretty. I think everybody in here is in a bad mood today. I'm picking up some vibes. I'm in a bad mood. You just don't want to talk to me. You have a terrible weekend and you just don't feel like talking. Now, see, like I said, everybody's in a bad mood. Everybody's in a bad mood. There's an example right there. If you have a negative W on the outside, you flip what's on the inside and you get a positive. Now, the first thing students say is when they see this thing, they say, well, I thought if you flipped it, it became a negative N and a positive N, or a negative M and a negative N. No, the one before this, what's the difference in that problem, that and this one? What's the difference? There's only one exponent and there's no big set of what? Parentheses. Different animal. This is a cat. This is a tiger. Different animal. They may have similarities, but it's totally different. The main thing is this big set of parentheses. That big set of parentheses is not saying, it says this whole thing is multiplied by that negative W. So if I flip what's on the inside of the parentheses, if it affects anything, it's going to affect the W, not the inside of this, because it's a parentheses quantity. And these are just examples. Like I said, if you get the final answer, x squared over y squared raised to the negative 4th power. And x to the 2nd times y to the negative 3 over z to the negative 4th. and that's to the negative fourth power. Now, both of these problems can be simplified even more after you do it, or something else can be done after you do make this a positive. First of all, I flip this, and that becomes y squared over what? X squared, and I raise it to the positive fourth. Now what rule can be used? Power rule. Power rule says that if you have something raised to a power, you can multiply the what? The exponents. And that becomes y to the 8th over x to the 8th. Now, could I flip it first and then distribute? Yes. Can I distribute then flip it? Doesn't matter. If you do it another way and you do it legally, you'll get the same answer. What about this one? What if I just bring this one up and this one down and I don't mess with this one? Will it change that, or will it change just these? It'll just change these because I didn't bring this one down. Okay? So that's another. I'm going to do it that way, and then I'm going to do it another way. So x squared z to the fourth over y to the third raised to the negative fourth power. Now, what if I wanted to make that negative 4 positive? What would I need to do then? Well, then I flip what's on the inside all the way, and then it becomes a positive 4. Or I can distribute this negative 4. It doesn't matter how you do it. Let me go ahead and flip it. Y to the third over x squared z to the fourth, and that's to the fourth power, and that's going to be y to the 12th over x to the 8th, z to the 16th. All right, now you do it another way and see what you come out with. Start back here and do it another way. Distribute the negative 4 first and see what you get. I guarantee you'll get the same answer if you do it right. What's negative 4 times 2? Negative 8, Hubert. Thank you, class. What's negative 4 times negative 3? Positive 12. Thank you. Negative 4 times negative 4? 16. Good. Now I can just bring this negative 8 downstairs, and that'll give me y to the 12th over x to the 8th, z to the what? It's a miracle. That's the same answer.
As long as you have 12, because I have the z on top. I have z to the 16th and 1 to the x to the 8th. Does it matter where they're placed?
Well, yeah.
It's going to matter.
I don't know. I think you did great. It's all about. Well, if you flip the whole thing, or
flip
just
the whole thing right off.
Okay, then it would be.
So why did
Then you
have
would get.
this?
Hold on. You get z to the 4th over x squared y to the negative 3rd raised to the what? Not negative 4th, but positive 4th. And now you would distribute that, and you get z to the 8th, or z to the 16th, over x to the 8th, x to the 8th, y to the what? Negative 4.
Negative 12. So when I flip it, I don't make that 3 a positive? That negative 3 stays negative?
Yep, when it's inside the parentheses, yes. If you flip everything upside down, if you bring all this down, and you bring all this up, it changes only this right here. Now, I did partial. If I brought this down and left the x up here, then that changes everything. That's a different method. Okay? I brought the y down and the z up, and that made my y positive and my z what? Positive. But my negative is still out here. Then I flipped it, the whole thing, and then it became to the positive.
So come up with this negative 12, and is that correct? See that y to the negative 12?
This is the answer right here. These two are the answers. Now I gotta do some more work on this, get this one to come out right, but it has to do with this y to the 12. But anyway, I would do it one of these two ways. That's the answers. Those two. I still gotta go over this. I think I made a mistake something over here because I've got everything except for, that should be a negative 16 and then flip it.
Oh,
It should be because it's supposed to be on the bottom. This is supposed to be a negative. Somewhere I messed up. Let me see what something happened. 3, 4. Oh, this is supposed to be negative 4. Oh. And X squared, there it is. That is negative 16. When you bring that down and bring this up, and you get y to the 12th over x to the 8th, y to the, or z to the 16th, which should be like that. There we go.
so you flipped it at the end and made it normal?
No, you don't want a negative. There's a negative 16 and a negative 12. So I brought y to the 12th up and z to the 16th down. That's what I did over there. I got those two. There's no certain way to do it. Just do it and follow the rules. The 4 rules that I've given you. You follow 5 rules. You follow them, and as long as you follow them and don't do anything funny, you'll be all right. I'll do another one. Wait a minute. X to the negative 4th, y to the 6th, over w to the 4th, z to the negative 1, raised to the negative 2nd power. So what can we do? Somebody name something. What do you want to do? Flip it on the inside, flip everything. All right, so that'd be w to the 4, z to the negative 1, over x to the negative 4th, y to the 6th, and that's raised to the what? 2nd power. Now what? Power rule. So that's w to the 8th, z to the negative 2, x to the 8th, y to the negative 12th. Now what? I'm sorry, what? Nope. What do you got that drives people crazy? Got two negative exponents right here. What are you gonna do with them? Erase them? What are you gonna do with them? Flip it. Flip just those two. And that'll give us W to the 8th, Y to the 12th, over X to the 8th, Z to the 2nd. All right, try to do it another way.
Why are you just switching?
I'll show you. Because if I wanted to expand this, it's W to the 8th over 1, Z to the negative 2 over 1, 1 over X to the 8th, 1 over Y to the negative 12. Now what? I just broke this up into that. Now what? Which ones are broke? Which ones do you not like? So what do? W to the 8th over 1, 1 over Z squared, 1 over X to the 8th, Y to the 12th over, and you put it all back together. So what's another way to do it? What if I didn't want to flip everything? Or I could make everything negative, so when I distribute that negative 2, it makes everything what? You can do that. I'll bring this one down. And I'll bring this one what? Up. And that'll give me X to the negative 4, Y to the, I'm sorry, not Y, Z. Z to the what? Is that negative 1? Did y'all just see that thing go across the board? Z to the negative 1, I'm sorry, no, W to the 4th. I'm having a brain bubble and this thing is not working. Y'all see what it's doing? I can't see it with my arm. Whatever. Battery dead. Battery's not dead on either one of them. They're acting funny. All right. X to the negative 4, and I'm going to bring the W up, and that would be W to the negative 4 over Z to the negative 1, Y to the what? Negative 6, and now to the negative 2, what will that give me? What is that negative 2 when I distribute? What will it give me? X to the 8, W to the what? 8 over Z to the what? Second, Y to the what? Something not right. That's a different answer. Something not right. Where? Where? Right here? Right here? Right here? I brought it down. It should be a negative right here, right? What did I do? That's what happens when you do 3 in one page. You get messed up. What was the original problem? What was the original problem? Somebody give me the original problem. X negative 4, Y to the 6, over W what? W to the 4th, Z to the 1st, I had negative first up there. All raised to the what? Negative 7. That's the original problem. Everybody check. It is a negative one. Okay, that's the original problem. Okay, I don't know what I've done, but somehow I've got my two jiggers mixed up. Let me check. All right. I can make this, I can flip it and make it positive, and that would be W to the 8, Z to the negative 2, or positive 2, W to the negative 8, Z to the positive 2, over, I'm skipping a couple of steps, X to the positive 4, the 8, sorry, and Y to the negative what? 12? And that'll give me Y to the 12th, C to the 12th, C to the 2nd, over X, Y to the Z to the 2nd. Okay, other than mess myself up. Let me go back and just do it over. Somehow I've gotten myself turned around. I'm going to leave that right there as the original. Start over because somewhere I've got myself mixed up. Best thing to do, and I'm going to do this, I'm going to write the daggone original 3 different times because I can't keep going back to the original and changing. So negative, or X to the negative 4, Y to the 6th, over W to the 4th, Z to the negative 1, raised to the negative 2 power. All right, is that, everybody agree that's the original problem? Okay, hold on. That's what I should have done to begin with. Go away. Yeah. And I'll erase all this. All right, so first of all, let's say I want to distribute that negative 2. All right, that'll give me X to the what? Negative 2 times negative 4 is what? 8. Y to the negative what? 12 over W to the negative 8 and Z to the what? 2nd. Everybody good? Now, I could take that Y and that W and flip them, and what do I get? X to the 8th, W to the 8th, over what? Y to the 12th, Z to the 2nd. That should be the answer. All right, I can also take these two guys, and what can I do with these two guys? I can flip them, and that'll give me Z to the 1st, Y to the 6th, over W to the 4th, X to the 4th, and multiply or raise to the negative 2 power. Now, can I flip both of these and make that positive and distribute? Or can I distribute that and then flip it? Does it matter? Should I get the same thing? Yes. So we'll go 2 ways here. First of all, I'm going to distribute the negative 2 using the power rule. Now give me Z to the negative 2, Y to the negative 12, over W to the negative 8, X to the negative 8, and if I flip everything, what does that give me? W to the 8, X to the 8, over Z to the 2nd, Y to the 12th. Is that the same answer? Yes. But what if I don't want to do that? What if I want to flip this and get a positive 2 and then distribute? Well, that'll be w to the 4th, x to the 4th over z to the 1st, y to the 6th, raised to the what? 2nd power. And then distribute that, what will you get? W to the 8th, x to the 8th, over z to the 2nd, y to the 12th. Same answer? Same answer. What other way could I do it? No, I want to do it because I screwed up that last board. Here, let's just flip it this way. Just flip the whole thing. And that'll give you, or that's what I was wanting to do. I want to make this one negative and this one negative. Bring it down, this one down here and this one up here. And that way, when that's the way I would do it. So x to the negative 4th, w to the what? Negative 4th, over y to the what? Negative 6, and z to the negative 1. All raised to the negative 2 power, and you're going to get x to the 8th, w to the 8th, over y to the 12th, z to the 7th. I don't know what I did in the last board, but you see that doesn't matter how you do it, you get what? You get the same answer. But evidently I did something quirky on that last board and messed up myself. Go ahead and write this rule down. You won't see it much in here, but you need to write it down in case you ever see it outside of here. That's called the rational exponent rule. The rational exponent rule says if I write a radical over something, if I put a radical, or if I take the square root, or the 3rd root, or the 4th root, or the 5th root of something, I can rewrite that radical as a rational exponent. So I can write x to the square root of x to the 1st as x to the 1/2 power. What's over what? Well, what is the 1? What is that called? That's an exponent, right? Exponent. Okay. Hold on. I know I do this for y'all. Okay. Exponent over what? Index. This is the index. This is the exponent. So what about the 3rd root of x to the 5th power? How would I rewrite that? How would I rewrite the 4th root of x to the 3rd power? Remember, your first 3 rules of exponents have to do with basically the math. What does the last 3 have to do with? The way it looks. Okay? So which one should you worry about? The first 3 rules. The first 3 rules is what's going to make it wrong or right. The last 3 rules, whether I give you credit for it or not, based on the way you write it as an answer. Okay? So the first 3 rules are mechanics. The last 3 rules is aesthetics. How something looks. Don't want a negative exponent. Don't want a radical. Don't want a, whatever. Oh, let's do another one. Let's do one more on the rational exponent. About the square root of x plus 3. What's that? X plus 3 to the what? 1.5 power. Exponent over index. What's the exponent of that parenthesis? 1. What's the index? 2. 1 over 2. Question. Right, complaint.
We need to put the test up.
We ain't ready for a test. I gotta go over scientific notation 11.1. And I got 10 minutes because I'm gonna shut it off at 10 so I can connect my 2 so I can get this video up. I'm gonna pull in my handy dandy scientific notation slide. Now, if I was to ask y'all what the definition of scientific notation was, what would you tell me? Whoa. Anybody got a definition? Yep. In any of the sciences, especially biology and chemistry, you're gonna learn how to do it. Scientific notation. You got to know the definition before you know how to do it. It's placing the decimal. Here it is, right here. Placing the decimal to the right of the first number. Hold on, man. I'm trying to. To the first number greater than 0. To the right of the first number. I'm sorry, greater than or equal to 1. Now, I love when students read this definition because they start to try to reinvent the wheel. All right. What do you mean, move the decimal? Well, first of all, if I write a decimal up here, let's go with 0.0000123. All right, the definition says placing the decimal to the right of the first number greater than 0. Well, which way do we read? So that means we're going to go along this number until we find a number greater than or equal to 1. Where is it? Boom! There it is. So where do I put the decimal? It's got to go to the what? To the right of the first number greater than or equal to 1. Period. So I've got to move it. Well, we're going to get into that in just a minute. 0 is 1, 2, 3, 4. 4 places. Now notice I ain't said anything about a sign or anything. That's where y'all get all crazy. But I just want you to know that that's how you. What about a big number, Hubert? $4,120,000. Well, where is the decimal on a big number, on a whole number? It's at the end. Which way do we read? This is the first number, greater than or equal to 1. So we've got to move the decimal. 1, 2, 3, 4, 5, 6. Notice I said 6. I didn't say a sign. I just said 6. That's how we move the decimal. So that way you don't ask, because the first thing I get when I'm giving, which way do we move it? Look at the number first. Look at a number. And that's why I put those two numbers up there so you can say, where do I move it? Most of us read left to right, so when we use a very large number, we look for two things, where the decimal is and where it needs to be. Okay? Well, I did that over there instead of right there. So, sorry, put my on the slides. Question. Right, complaint. Turn. I didn't know I had all that on there. I'm sorry. Okay. Now look at that number, and then I'll show you the other one. Look at that number. Write those two numbers down. One of the biggest problems students have is they think they know how to do something, and what? They don't. And sometimes people remember just enough about high school math just to get themselves in trouble. So that's why I'm going over this, to make sure everybody understands where to put the decimal. I'm not saying anything about signs, where to put the decimal. So in this case, the decimal goes right there. In this case, the decimal goes right there. Placing the decimal to the right of the first number greater than or equal to 1. So the first number, boom, right there. Sorry, my board does not want to work today. Right there. And right there. I had to use these because U's didn't look good. And I'm still trying to learn how to do the PowerPoints, the symbols. So anyway, 5 places, blah, blah, blah. Okay, now, here's our 2 numbers that we just learned that we moved the decimal. We got to move the decimal. Got to move it right here and right here. Everybody agree with that? And I said we move it 8 places and 5. So I put a blank right here. These blanks represent the sign that will be used. Okay? Now, this is the way I teach my students because this is the way I learned it. And it has helped me out tremendously. So if you at any time suck at scientific notation, or don't even know if you suck at it, then you use this little trick that I use, and it should help you. Ask yourself mentally, which way? This is now let's talk about mentally, because some of y'all don't have a good definition of mentally. It means what? In your head, in your brain. Do I say move the decimal, or do I say ask yourself mentally? Ask yourself mentally. Here's the question. Which way do I need to move the decimal in my head till they get the original form? This is the original form, and this is the original form because it's what we started with. So, in the first one, I didn't realize I had the same number here until after I did the PowerPoint. That's all. 2.15 on the first one up there at the top. I need to move the decimal right here. Which way do I need to move this decimal in my head to get the original? To what? Yeah, right here. You're right. Yeah, left. And that makes it a what? Left means what? Negative. Which way do I move this decimal in my head to get it back the way it was right here? To the positive side, and therefore it's positive. Now, the reason I do this, and it's supposed to put them there, if it doesn't, I messed up. But anyway, yep, there it is.
So the normal will show positive 8, would you show 8?
Yeah. It's supposed to do both of them. It didn't do it. Okay, this may not be the method that you remember. This is a method that I use to help with future calculations. Most students don't have a problem with scientific notation as far as write this as scientific notation, or rewrite this number in scientific notation, or write the number in scientific notation in regular notation. Most of you don't have a problem with that. You have a problem with the calculations, the operations with scientific notations. because of this one thing right here called a sign. And I'll show you what I mean in just a second. There it is. Okay, look at this one. 30 times 10 to the 9th times 2 times 10 to the 4th. This is what you'll be tested on. All right, now everybody in here can do 30 times 2. What is 30 times 2? 60. So you go down here and you put 60, and then you say, okay, 9 plus 4 is what? 13. And your answer is 60 times 10 to the 13th power. Now there's nothing wrong with that, only the directions tell us to write as what? Scientific notation. Is 60 times 10 to the 13th, is that in scientific notation? No, it's not. What is the definition of scientific notation? The decimal to the right of the first number greater than or equal to 1. So where will we have to move that decimal? We need to move it one place, because right now, it's right here. Where does it need to be? It needs to be right here. So I move it, and I get 6.0 times 10 to the 13th blank 1. That's supposed to be a blank. Okay? And I mentally ask myself, which way do I move this decimal to get it back? I'm about ready to quit. To get it back, to looking like this. To the right. And that's from the positive, and that's your answer. Some people put a negative. And if you put negative, you've done 90% of the problem correct and got 100% of it wrong based on that last little step. Look at the next one. You might want to write these down because they are examples. I just didn't write them down by hand. It's 203. We'll look at one more. Oh, what have you actually done? You basically multiplied 30 billion times 20,000 and got 600 trillion. That's basically what you did. I gave a problem like this out to somebody, a class, and I actually had a girl sitting about the second row right there. You never guess what she did. She wrote this right here. And she was multiplying all them zeros and multiplying. Took up half the side of her page when all she had to do was scientific notation. She missed the boat, and she missed the train on the way to the boat. I mean, she didn't just miss the boat, she missed everything. I went through the whole scientific notation, went through the whole spiel. And I told her to multiply these two numbers, and she's over there 5 place values taken up, 0 times 0, 0 times. She had the whole half of her page as one big calculation. What do you tell a person like that? Think about it. What would you tell someone like that? And be tactful. Anyway, how about this one? 45 times 10 to the 12th divided by 3 times 10 to the 4th. No. 45 divided by 3 is 15. You still got it. And then 12 minus 4 is what? 8. So your answer is 15 times 10 to the 8. And that's okay if you're not told to write it in scientific notation. That's just called regular notation. It's not a big deal. We're going to have to move it one place, and then which way do you move this in your head to get it back the way it was? to the right, so that's a positive, so it's to the 95. Now, I'm going to stop there because one, we still got to cover 11.1, and I don't want to rush this, and I want to do the video, so I'm going to go ahead and cut it off today, and I'll take the roll, and y'all can skedaddle. But I will tell you some updates here in just a second, so y'all won't be leaving asking me 15 questions all about the test.